Ryan with Miss.Geek here, and welcome back to the BITX40 rebuild series. This is part 3-ish. This is going to be probably part 3 and 3.1. But in this part, we're going to discuss the VFO and BFO and how I'm going to be putting that together. I touched on it in the last video, but basically, what we're going to do here, I've got my hard cider here, thanks to my daughter who accidentally got me a cider instead of a beer, but that's cool. It's quite good. It's apple cider. I'm not big on apples, but it's pretty good. So we're going to be using a QRP Labs SI5351A synthesizer board. These are about, I think it's $7.75 US on QRPLabs.com, and it's no secret that I'm a big QRP Labs fan, and I have been ever since I purchased the QRP Labs SI5351 based VFO, which was my first purchase, which was for this. In fact, I have it around here somewhere, but it was the VFO kit, which includes this synthesizer and it's 16x2 LCD and a couple switches and one of these, a rotary encoder, and it's a complete fully programmable VFO. It is feature complete as is. However, there's some features that I want that it doesn't include. So I'm going to build my own VFO. For one, it does not make multi-band. It's basically a signal generator. It's sold as a SIGGEN / VFO kit, and that's what it is, and it's a wonderful kit for that purpose. However, I'm going to want to do some programming in this that is different. Another ham, who I'm going to go into this later on, has actually given me an Arduino sketch. Sorry, I can't think of the words. Has given me an Arduino sketch that's just for this, and I'm not good at art programming. I don't actually care about being good at programming. I just want to be able to do the things I need to do. However, I can modify scripts that are already made and scripts and programs, but I'm not really good at writing them from scratch. So I'll get into that later, and I'll do some shout outs there, of course. But this is the basic kit here, and it's got, or the board, and it's got a few parts that go on here. There's a couple of, there's a voltage regulator and some passives, and a couple of BS170s being used as level converters, because the SI5351A is a 3.3 volt chip. You can see it's pre-soldered there, but it's going to be in a 5 volt environment next to this Arduino Nano. And in the last video, I showed an assembled Arduino Nano. However, I'm going to be using an unassembled Arduino Nano because I'm probably only going to connect the pins that I'm going to need to use, or at the very least, I may connect them upside down so that the board can sit lower, and just, maybe hot glue it here, and then I don't really know. I haven't decided, but what I have decided is that this is going to live as close to everything else as possible. And so it's probably going to get mounted. I'll have to put something down here so that it doesn't short out, but it's probably going to be mounted right around here with the one of the clocks just connecting directly right here, and the other one just over here. I could even, use a standoff or something and mount it right here. Probably not going to do that because I'm just going to use the board space available instead of stacking. Usually stacking doesn't go that well for me. Plus, I want to keep the profile low. I'm not sure what case I'm going to put this in. I don't want to build myself into a bigger case than it needs. I'm also not sure how full featured I'm going to get, if I'm going to go multi-band or not. I'm going to at least get it working at 40 meters. And so that's what we're starting with. That's what my sketch is for. And that's what we're going to use. Now, I do know I'd like to use this 20x4 LCD. If you have seen any, well, actually, I don't think I've really talked about it in any of my other videos. I like screen space. It's kind of a fetish of mine. My computer has 4 screens, and I use them. I use them for work, especially because I work from home for a company. But I like lots of screen space. I don't like seeing things behind menus if possible. I like to just see them right up front. So I'll be able to see, of course, frequency, upper sideband, lower sideband, and what band I'm in, just whatever information I want to display. There's 20 by 4 characters is 80 characters. That's a lot of characters I can use. And so, who knows, maybe I can create create memories that have descriptions. You know, I can do whatever I really want with it, but I like the big screens, and I cannot lie. And it's I2C, which means it just needs power and SDA and SCA and SCL. Whatever. It it just talks to the same bus that this does, and makes it really easy to connect instead of having all of those 20 pins or whatever. So real simple, and these are cheap. I don't remember how much I paid for it, but it was a few dollars, probably around $8 or $10. And so I've got some switches, I've got all the stuff that's going to take to make that work. But the first thing I got to do is build this little guy, and that's what I'm going to do next. I'm not going to video it because it's just frankly really boring, but I'm going to show you what I do for the instructions. Now, some channels will tell you print the instructions in full color and put it in a binder, and for the bigger projects, maybe that's what you want to do. I don't know, but I've never done that. I've just got an old 10-inch tablet here that I use for kind of everything, and I just download the PDF. This one's only 5 pages, and there's the complete instructions for it, including troubleshooting options. So, I mean, it's just so simple. I really can't really argue with how simple this is. I think there's only a few pieces here. I mean, it's a very simple kit, and doing this means that if I want to zoom in, I can take a good look at the directions. So I'm going to go follow these directions, and I think this will only take a few minutes. So let's see. It is currently 10:33 p.m. my time while I'm doing this, which is probably why I'm stammering a lot, because I'm tired. It's been a long day. A good day, but a long day. And so I'm going to get started on this, and I'll come back. And actually, this is not the assembly manual, I don't think. Yeah, this is assembly manual. So anyway, I'm going to get started on this, and I'll come back, and we'll have a completed device. So see you in a few minutes. All right, so we're back, and we've actually got the construction of the SI5351 board complete here. And you might wonder why I purchased these instead of buying like the Adafruit ones that are already put together. One, I like building things. That's kind of a big thing for me. But two, this is supporting QRP Labs. Hans supports the QRP community, so I think we can show him some appreciation for that by supporting him. This costs roughly the same or less, and it contains. By the way, I got a free resistor. So I mean, come on, Adafruit doesn't give you a free resistor with your purchase. Anyway, so the only thing left to do is to get all these little capacives installed, or to get all these components installed. Took me 15 minutes. There's 6 resistors, 3 capacitors, a 3.3 volt voltage regulator, a couple BS170s, and a 27 megahertz crystal. And those, 10, 6 plus 3 plus 3 plus 1, it's 13 components. Took me 15 minutes to install. Now I've got to install the headers. I am going to install the header pins per the plans. I decided I'm not going to try to mount it flush to the board or anything. I'll explain why later. But I do need to solder those in. And the easy way to do that is to use some header pin sockets. And these sockets are not soldered in, but they're just kind of on there to give me the spacing. And then I'm just going to solder on a couple of these. And yeah, it's totally wobbly, and I don't care. I'll explain what I do here in a minute. Okay, so now that they're on, I'm going to take this wobbliness and just unwobble it, and now I can do the rest of them. So I like to do them in an order that I don't heat up one part of the board over much. So just hold it for a couple seconds and get that solder in there, and then come over here and do the same. Kind of like when you're torquing head bolts. If you've ever replaced a head gasket, you go in a kind of a circular pattern. I'm just trying to not generate too much heat in one spot. Is really what I'm going for. I can remove my little helper here because it holds it now, So I'll do this and I'll come back and explain the next step. Okay, we're back, and what we've got going on here, the next step here is to calibrate the crystal oscillator. We have to know the exact frequency that it is so that the SI5351 can be set for as a base or a reference frequency. Currently, we don't know what it is, but if you've watched the previous videos, you probably have an idea about what I'm about to do here. So I mentioned that my first QRP Labs purchase was the SIGGEN VFO kit, which is what this is. And what we're looking at, I think I've showed this in another video, but I'm not sure. But what we're looking at here is the QRP Labs receiver kit with a 40 meters, 7 megahertz bandpass filter, and the filter board that filters the sideband, the polyphase network board. And that works beautifully, by the way. It works beautifully with this SIGGEN, because the SIGGEN essentially is tailor-made to work with that. Well, it'll work with lots of things, but I can set the reference frequency. I can set the multiplier to 4 times. So this works on quadrature, takes in the 4. Anyway, you get the idea. It works with this. What we're doing here is I set the multiplier to 1 so that it's just on 10 megahertz. And I've got our new board in here. I had another one in here that I did not calibrate. I just was using it as was, but or as it is, as was. Anyway, but it's in there, and what I'm going to do, sorry, shaky cam here. I've got Spectroid up, which is a nice little Android app. You can see it moves when I talk. And I've got my Kenwood set at 9999 megahertz, 9.999 megahertz. And so when I output 10 megahertz, I should hear a 1000 hertz tone. So let's crank up the volume here. And there's the tone. It's at 1066. So it's at 1066 hertz. So what I'm going to do now is I'm going to go in here and I'm going to mount my phone for this part. And I'm going to put it in its mount and come right back. All right, so I've got it set up here so that I can see the frequency. But what I'm going to do is I'm going to go in here to the menu, and I'm going to go to the, let's see here, clock 1 frequency. It's right in here somewhere. There it is, reference frequency, 27.00004. So I'm going to go down a little bit here. Let's see, we'll change that. We're going to do 3. So we're 66 hertz high. Assuming that my Kenwood is perfect, it might not be. But we're going to assume that it is. I was 66 hertz high, so I'm going to go down by. We're going to go to 3990 and see what effect that has on it. Okay, it didn't have any effect. It's still at 1066. So let's just try it a little bit more drastic here. There it is. We'll just go to 3900 there. And, oops. Okay, now it's at 1102. So it looks like we went the wrong direction. So let's try it again here. Oh, I'm in the wrong menu. There we go. Now we're at 1020. So we'll just add 10 hertz to this. And it's still at 1020. I need a more bigger change. $1,008. We're almost there. Okay, now we're at 984, so I gotta roll it back a little bit. Kind of the fun of doing this, I suppose, huh? There we go. $996. I'm gonna go for perfection here. Why not? Yeah, still 996. I'm actually just going to leave it at that. I think that's as close as I'm really going to get. So now I need to take note of this value. And the way I'm going to do that is... I didn't want that. Alright, so this is the reference value for this device. So the way I'm going to take note of this is I'm going to take a picture of it. And I don't have a label for this one. Otherwise, I would just label it. I do have some tape around here. I should probably do that. But somewhere I have some masking tape, which would be perfect for that. But anyway, now I know what the reference frequency is, and I can use that in my sketch. So in the next video, I'm going to cover actually building the VFO from this using the sketch. We've got our Arduino Nano, and we have our QRP Labs SI5351, which I did not take a picture of that, unfortunately, while I had it on, but I can just turn it on again if I want, or I'll just rewatch the same video, and I've got it. Anyway, thank you for watching, and if this is at all interesting to you, or you like watching me fumble around with dumb things and have fun, then please subscribe, tell your friends, and go to my blog. And, you know, I don't really talk about my blog enough. Go to miss.geek.com and read the things I write, because I'm an author, and, well, I'm not an author, I'm a writer. Okay, I write things, and writers like it when people read their stuff, because, you know, we like hearing ourselves talk, basically, is what it comes down to. I mean, tell me that's not true. It's true. All right, thank you for watching, and we'll see you next time, 73.